Colloids, also called colloidal dispersions, are mixtures in which you have a dispersed substance finely divided in a dispersing medium. So what does that mean? Particles in a colloid are larger than particles in a solution. They're typically on the order of 1 nanometer to 1,000 nanometers. So significantly bigger than most molecules. What we see with a colloid is that it is not a clear liquid. It's either somewhat cloudy or very cloudy. And the reason for that is that the particles, the colloidal particles, are large enough that they interfere with the light passing through. In a solution where the particles are on the same size as the solvent particles, they're on the molecular size, those particles aren't large enough to interfere with light passing through. So they appear clear. Under a microscope, particles in a colloid have a distinctive jittery motion. It's called Brownian motion. And it's caused by collisions that these particles have with molecules in the liquid. Colloids are neat because these particles are actually large enough that you can see with a good microscope, and so you can observe this. So let's look at this video. This is pollen grains in water. They look like they're alive, don't they? They're not. So this is called Brownian motion after the scientist who observed it. His last name was Brown. So Brownian motion is a very random motion, and it's caused by the individual particles running into and being bombarded by the water molecules or the solvent molecules. It's a bit like, a crowd with some beach balls, right? You get a big crowd and they're hitting the beach balls around. That's sort of what this Brownian motion is like. If you add soap to water, soap molecules are larger than water molecules, and they form micelles. We talked about this a little bit before, but here's an illustration of the micelles. It's better than the one I drew. So here you have your soap molecules with their ionic heads and their nonpolar tails, and they sort of form this, it's like a circle of wagons, right? So they put all of their nonpolar tails in here because those guys feel real comfortable together. They put the polar heads out here because that interacts with the water. And so we form these little microglobs of soap. They're spheres. They remain in suspension because there are forces of repulsion between them. So it's got this ionic head, and these ionic heads are repelling each other. So soap will form a colloidal suspension. You can also do this with macromolecules such as proteins. There are different types of dispersions, and we tend to give them different names. We don't necessarily think of them as dispersions. Fog is a dispersion, a colloidal dispersion. It's categorized as an aerosol because you've got a liquid being dispersed in a gas, so little water droplets. A solid aerosol, smoke would be an example of this, where you have pieces, you have solids suspended in air. Whipped cream, I think some of us probably had that over Thanksgiving. Whipped cream is considered a foam. So you have gas distributed in a liquid. An emulsion is a liquid in a liquid. So milk. The milk you buy at the store has been homogenized. That's a process that allows the milk fat to remain dispersed within the aqueous portion. If you have raw milk and you let it sit, the fat will rise to the top. And then when they skim that off, what remains is the skim milk that doesn't have any fat in it. And you can also have solid emulsions. Opals are water dispersed in silica glass. And those little bits of water in there and give it that beautiful, shiny quality. The Tyndall effect. So with a colloid, sometimes there's enough of the suspended particles that you can just see that it's cloudy. Other times you can't. And here's an example. Here we have two liquids. This one is a colloid, and this one is a solution. When you shine a beam of light through the colloid, you see that the particles are large enough to scatter the light. That does not happen in a true solution. You can't see the beam of light. This is a lot like the sun streaming in through your windows, and if there's dust in the air, which there usually is, you can see the sunbeams. Are you actually seeing the sunbeams? No, you're seeing the reflection off the little tiny dust particles in the air.